Today's lesson is on estimating square roots. Our objective is, given a square root or a cube root, I can estimate a decimal that is within the nearest tenth. So first let's review what square roots are, and you should write this down in your notes, specifically this piece right here, so you know all of your perfect square roots. But basically, a square root asks what number times itself equals that number. So for example, the square root of 4 is 2 because 2 times 2 is 4. The same as the square root of 9 is 3 because 3 times 3 is 9. And the square root of 16 is 4 because 4 times 4 is 16, and so on. So pause this, take a minute, and write down. You're going to want this list of perfect squares in your notes and what they're equal to. And the problem comes in what happens when we have something that is not a perfect square, such as the square root of 34. If you look up here, there is no square root of 34. So I have to ask myself in this list, what numbers are the square root of 34 between? And if I look up here, 34 is between 25 and 36. So I can write it out like this, where the square root of 34 is somewhere between 5 and 6. So I ask myself, is 34 closer to 25 or closer to 36? Since it's closer to 36, it's going to be approximately 5.8. Because if you think this is 5, and this is 6, halfway between there is 5.5, or 5.5, and so it is, so I could write that 5.5, and then the 34 is going to lay somewhere around here. I could even divide this up if you want to 5.6, 6, 7, 8, 9, so maybe a little bit even past the 5.8. So the other thing you can do is now check that with a calculator, and what you'll find is that this is a never-ending decimal, and we just estimate it here to the nearest tenth. So the next one is the square root of 11. If I go back up here, square root of 11 is between which two perfect squares? And that would be 9 and 16. So I would go down here, square root of 9 is 3, the square root of 16 is 4. Halfway between there would be 3.5. And the number 11 is closer to 9 than it is 16, so I would say it's somewhere around here. So I could estimate it to be about 3.2 or so. Again, this is just an estimate. So let's try a few. First of all, square root of 18 would be 4.2 because it's between square root of 16 and square root of 25. The square root of 60 would be 7.7 because it's between the square root of 49 and the square root of 64. Square root of 5 is 2.2. Square root of 38 is 6.2. Now, cube roots are very similar, except that instead of 2 numbers, it's 3 numbers. So, for example, the cubed root, notice the little 3 here, of 8 is 2, because 2 times 2 times 2 is 8. And the cubed root of 27 would be 3, because 3 times 3 times 3 is 27, and so on.